In this video, we're going to review another project valuation technique, net present value, or NPV. And NPV is a pretty common technique. In fact, a study by Duke University a few years ago found that 75% of the CFOs that they surveyed used NPV analysis as their primary capital budgeting technique. So if the CFOs use it, you should also know what it is and how they plan to use it against you. What NPV does is it takes into account what's called the time value of money, which is that a dollar today is worth more than a dollar tomorrow. And as a reminder, that's not just because of inflation, but also what you could have done with that money, like invest it in another project. So the concept is also called the opportunity cost of capital, which is the fact that you're passing up other high return stuff that we could have done with that money instead of giving it to you for your project. The idea of discounting is that we're taking into account that the future value of an amount of money is less than the present value of that same amount of money. And that's for the reason stated before, that we could have generated a return with that money. There's an opportunity cost in not having that money now in the present to do stuff with. So how do I account for that? Well, I do it by discounting the cash flows. And here's the formula to do that. And at first glance, it might look harder than it actually is. But the idea is that you're taking whatever net cash flow you have, and that includes your gross profit and your costs from the profit equation, and adding the timing of when the cash flows occur. And the idea is that you're taking whatever net cash flow you have, and that includes elements of revenue and your costs from the profit equation, and you're adding the timing of when the cash flows occur. And the cash flows you put into the formula will be positive if it's gross profit and negative if it's a fixed cost. And one of the key factors in the formula is that opportunity cost of capital that we talked about, which is R in this equation. And FYI, generally, you're not going to just come up with that number yourself. The capital committee or the finance department typically defines that number and asks that all projects being submitted use the same number so that they can compare projects using the same yardstick. And the number actually might change over the years, just given a particular business condition at the time. And companies sometimes have different R's that they use for projects in different countries, for example, so they can account for different levels of risk and business conditions. And the time periods we'll assume are in years. So for each year from year 1 to N, even if we had the same exact cash flow, but it was some number of years into the future, that cash flow would have less value than if we had that cash immediately in present value terms. And the formula accounts for that by dividing those future cash flows by a little bit more than 1. It does that by adding the opportunity cost of capital, the R, to 1 in the denominator. But then it also takes that sum, 1 plus R, to the power of whatever year the cash flow occurs in. And that makes the denominator a little bit bigger than 1 as you go forward, and that makes the quotient smaller than the undiscounted number was. And that's especially true the further out that you go. Because let's say you're 10 years out, well, your factor, the exponent is going to be 10. You're taking that denominator to the 10th power, and that's going to make the number a lot smaller than, say, if you were looking at the number in the third year. All right, that's a lot of detail, and I think this approach is going to make a lot more sense once you've gone through one of these analyses. So we suggest you go through the PDF that we've got for you, a short exercise that you can do to get some practice. So look for a separate link for that document and possibly a video debrief of the exercise as well. Okay, thanks a lot.